My name is Chidema Zik Ikor, and I work with the UN Environment Program Crisis Management Branch here in Geneva. It's a pleasure to host this webinar as part of the webinar series of the Global Network on Environment and Oil and Gas. So today, this is our first webinar in the webinar series for 2020, and we focused on chemicals and waste management in the oil and gas sector. And I hope that the discussions today will give an overview of uh, some of the key environmental concerns associated with chemicals and waste management in different stages of oil and gas production and exploration, as well as identify waste management options, best practices, and international guidelines in this area. This webinar is being organized by the UN Environment Program, UNEP, which works in partnership with Norway's Oil for Development program. You might be wondering why UNEP is involved in this sector. Well, while the long-term goal of the UNEP is to reduce the world's reliance on fossil fuels to fight climate change, we also recognize that oil and gas will remain part of the global energy mix in the foreseeable future. Therefore, UNEP's work in this sector is to ensure that oil and gas are produced in an environmentally and socially acceptable manner and do not impact negatively on local communities. So in this regard, we are currently collaborating with Norway's OFD program, which works in 14 countries in Africa, Asia, and Latin America, where we provide capacity building and technical assistance on environmental best practices in oil and gas exploration and production. Also, an important part of our work is to disseminate knowledge and best practice in this sector through global outreach, such as this webinar series. On this note, I would like to introduce our presenters today. Joining me today is Mr. Mike Cowan. Mike is an award-winning environmental scientist who possesses over 30 years of international experience within environmental and waste management sectors. Throughout his career, he has operated in more than 50 countries globally. Over 10 of them are in Africa. Mike also led UNEP's groundbreaking work in Ogoniland, Nigeria, and he has also worked with environmental and waste management issues related to the oil and gas sector in Africa, the Middle East, Southeast Asia, Europe, and the Eastern Caribbean. It's good to have you here with us, Mike. Also, our second speaker for today is Dr. Ian Goodacre. Ian is a business development director and soil and groundwater expert within the global division of the RSK Group, and he has over 25 years of varied research, environmental consulting, and project management experience. He also specializes in environmental due diligence, quantitative risk assessment, remediation, and waste management. For the last 6 years, Ian has worked in the Middle East, mainly in Iraq and more recently in Africa, where he managed the environmental and geotechnical projects for international oil companies. Glad to have you here with us, Ian. And so before we begin, I would like to lay a few ground rules just to allow you, if you're joining us for the first time on one of our webinars, to let you know how the webinar is going to go. So we'll start with both presenters presenting, giving their presentations, and then we'll also have a dedicated session for the question and answer uh, session. So unfortunately, the attendees will not be able to speak, but you'll be able to post your questions using the chat or question function, which you can see on your screen. We'll also like to let you know that the presentations that we'll be giving today are available for you to download in the handouts using the handout function, which is also available on your screen or on your app. This webinar is being recorded, so the replay will be available for you to share with your colleagues or with your network or for you to review. So at the end of the webinar, after the question and answer session, there'll be a survey for you to fill out, and upon completion of this survey, you'll be able to get your certificate of participation. So we'd like to kindly request that you stay till the end of the webinar to participate in this survey and then get your certificate of participation. We also finally would like to let you know that you have been automatically subscribed to our mailing list, where you get updates on upcoming webinars, news, job opportunities, and much more from our newsletters. So we'll be going to the presentation, and our first presenter will be Mike. So Mike, over to you.
Chi, thank you very much. Let's just get my screen up. Jolly good. Well, Chi, thank you for that glowing introduction. I hardly recognize myself. So thank you for joining. Chi's outlined some of the guidelines, the rules. You can raise questions as we go along, and I think Ian and myself will receive them in a typed format, and we can respond at the appropriate time. So if there's anything that you're not clear on, anything that you would like more information, do please send the question through and we will endeavor to respond. So my first session, I've got about 20-25 minutes. I have the challenge of presenting to you in that time what is generally a 4-day training workshop. So it's going to be a very simple overview to the topics of the use of chemicals in the oil and gas sector and the related topic of waste management. So as I say, it's a very quick overview. I'll run through a number of slides, and as I say, forgive the brevity, but it's just really to give you an understanding of the broad topics, the broad themes in the sector, and thereafter Ian's going to give a far more detailed presentation on some actual case studies which will illustrate some of the points, I think, very nicely. So moving on, the first topic we're going to talk about is chemicals within the oil and gas sector. And what that's going to contain in this brief section is going to be, we're going to set the scene talking about chemicals in the oil and gas sector. Some of the particular more problematic chemicals we'll talk about, and we find those particularly in drilling fluids. We find them also in the production chemicals. We'll then briefly run through some of the key national and international legislation and regulations, how we govern, how we regulate the use of chemicals. We'll talk a little bit about the classification of hazardous substances, and then we'll talk about material safety data sheets. And we'll wrap that up with just a few of the key learning points that will have come out over this presentation. So as Chi did mention, the oil and gas sector is here. It's here to stay. Love it or hate it, it's here, and we see it as our responsibility to work with the oil and gas sector to ensure that its operations are undertaken in the most environmentally and socially acceptable fashions. So this slide talks to us a little bit about what the present level of energy from the oil and gas sector is. Energy generation, 575 exajoules, and serving something in excess of 6 billion people around the planet. But it is noted there that in excess of 1 billion people presently have no access to oil and gas. And if we look at the energy equation in the globe, we see that oil and gas is producing a little bit over half of the global energy source. Moving forward over the next 15 years or so, we can see that there'll be an anticipated generation of 720 exajoules, so an increase in production of about 25%, serving a population of something closer to 9 billion. So over that timeline, production is going to be increasing, efficiency is going to be increasing, utilization increasing, with only a very modest fall in the proportion generated by oil and gas, down to about 49%. So over the next 15 years, we are not going to see a major reduction in the use of oil and gas globally. It's here to stay, we have to make sure that it's underdone, as I say, in the most environmentally and socially responsible fashion. Throughout the life expectancy of the oil and gas sector, chemicals are used, let's say, from cradle to grave. We're focusing on the exploration and production side of things, and within this particular module, chemicals are used throughout, whether it's at the time of exploration drilling, logging and testing, well completion, field management, workover and stimulation. Bottom line is, whatever link in the chain of the oil and gas sector, hand in glove with that is the use of a very large and complex number of chemicals. Moving on, I'd just like to reiterate the fact that if I'm speaking too quickly, if you're not able to understand something I say, do send a question through and Chi will filter that and I can reiterate or clarify any point. So just to emphasize, there is a very broad range of chemicals used in the sector. Chemicals used in drilling, cementation, cleaning, completion fluids, and then ultimately production fluids. The range of chemicals used is very broad, very complex. Some could be organic, some inorganic. Some may consist of just one single component. Some is a cocktail of different components. And what we're interested in the risk to environment and the risk to health. So to be able to make informed decisions, we as environmental practitioners need to know all of the components of a given set of chemicals such that we can manage those risks to the best of our ability. There's two broad categorizations when we talk about chemicals. Firstly, harmful, and then secondly, hazardous. Now, when we talk about harmful, these can cause an adverse effect on the environment as a result of the amount of product that's put into the environment, the time, the nature of the receiving environment, concentrations. So they can have a negative effect, but they're not in essence hazardous by nature. Those chemicals which are hazardous by nature, they cause adverse effects due to their intrinsic properties, which could be their toxicity, their tendency for bioaccumulation, and other factors such as what is their rate of degradation within the environment. So an important definition, harmful and hazardous. They're not the same and they're not managed in the same fashion. Moving on, one of the biggest aspects in oil and gas as it pertains to both chemicals and waste management is the drilling fluids which are used. Drilling fluids are a major component of the sector and present major environmental and public health concerns. When we talk about drilling fluids, there's primarily two categories of drilling fluids. There's the more simple water-based drilling fluids, the acronym being WBDF, water-based drilling fluids. And then there's the more complicated, potentially more hazardous oil-based drilling fluids, OBDF. And as the name suggests, the water-based, the base material is water, oil-based, the base material is oil. So you could think about the differences similar really to a water-based or an oil-based paint. Very much the same phenomenon applies to these drilling fluids. In more recent times, there's been a third category of drilling fluid developed and put into the marketplace. These are synthetic-based drilling fluids, where the oil has been largely replaced by more modern synthetic chemicals. As I mentioned, water-based drilling fluids are by far the simplest, and they are by far the most environmentally benign. And they're also the cheapest. So given the choice, oil engineers would, as a first port of call, use water-based drilling fluids simply because they're cheaper. However, they do have limitations, and that being that they're not good for use in deep, complex drills, drill sites which are horizontal, or where we have particularly complicated geology. That's where the oil-based drilling fluids, or more latterly, the synthetic drilling fluids, come into play. Now, drilling fluids have been around as long as the oil and gas sector have. We go back to the mid-1800s, and the chemistry of drilling fluids has evolved quite significantly. At the start of the enterprise, drilling fluids were largely water and clay, but more latterly, there's been a greater infusion of chemicals and hydrocarbons, and more latterly, synthetic chemicals. So it's an evolution, and that process of development continues to evolve today. When we talk about drilling muds, a very quick slide here which shows us some of the additives here on the screen of what is added to a typical drilling mud. And we have on the left-hand side here salts and brine polymers. They're used as an inhibitor. We have viscosifiers, typically clay, to give the necessary viscosity to the liquid. We have shale and scale inhibitors. These prevent the generation of scale and shale. We have lubricants to reduce friction of the moving parts of the drill. We have defoamers, typically aluminium stearate, for minimizing the generation of foam, corrosion inhibitors, biocides, etc., etc. So it's a cocktail of chemicals. Each of those chemicals comes with their own environmental and public health risks. And we, as environmental practitioners, need to be familiar with the components and familiar with how best to manage these components. Bottom line is, drilling chemicals, drilling fluids are a cocktail of different chemicals. Moving on, as I mentioned before, the water-based drilling fluids are comparatively benign. If they're used offshore, then typically offshore, they would have little effect if discharged into the marine environment, depending on the depth and the location in relation to the shoreline. But it's not uncommon for water-based drilling fluids to be discharged into the marine environment. The picture on the slide here is a picture I took diving on a rig in the Philippines, and we can see quite simplistically, the lower part of the picture there is where the water-based muds have been discharged. It's not a hazardous, it's not a toxic impact. It's more harmful where it's a physical covering of the seabed, but in a relatively short period of time, that seabed is going to recover. That said, we don't encourage the discharge of water-based drilling fluids in a terrestrial, shore-based environment, because they can have elevated pH, they can have elevated salinity, which are not necessarily an issue within the marine environment, but within the terrestrial environment, they probably are going to need to be contained and treated before disposal. Dealing with the more complicated, the deeper wells, more complex geologies where we're using the oil-based muds, these muds are a cocktail of chemicals, many of which are toxic or hazardous. They are not allowed to be discharged within the marine environment. Similarly, they're not allowed to be discharged within the terrestrial environment. They need to be contained, managed, treated, and finally disposed of. Due to economics, all drilling fluids will be reused, recycled to the extent possible. But there comes a point after which they will have to be disposed of. And that's where some of our greatest challenges are encountered. As mentioned previously, we have a host of chemicals used as production chemicals. As you can see there in the slide, some of the chemicals are what we would call green, yellow, or sometimes red. That's a form of simple categorization which denotes the level of hazard. So simplistically, green listed chemicals, relatively benign, yellow, medium, and going through to the red are the chemicals of greatest environmental and public health concern. We talked earlier about biocides. These are an example of a component which may contain red chemicals, red flag. We need to be aware, we need to be concerned, and we need to monitor and manage it very carefully. So the chemicals within the drilling sector will typically be discharged within the host environment. Many of them will be contained within the produced water. What is produced water? When we strike an oil reservoir, it would often be in conjunction with a lot of water. That water also gets liberated through the drilling process, and that's often referred to as produced water. The produced water may contain a lot of chemicals, may contain a lot of hydrocarbons. They need to be managed. In more sophisticated operations, the produced water can and should be reintroduced back into the underlying geology. Often isn't done because it's a complicated process. Therein we end up with a disposal, a chemical problem. And again, produced water is a large chemical holding body, is a large waste management consideration that we will have to encounter. We talk also in the gas treatment side of things, a number of chemicals are introduced to manage the gas, to control the production and the quality of the gas. Very often, these chemicals which are added are going to be injected and then will be exported along with those gas. So again, from cradle to grave, we have a chemicals management issue to be aware of and to deal with. Okay, moving on, talking about the classification of chemicals, the classification of hazardous substances, and we have here again an articulation of this color coding: green non-hazardous, yellow or orange hazardous, red very hazardous. Now this color coding is done in conjunction with international conventions, international agreements, such as the United Nations Global Harmonization System, the acronym being GHS. You may have heard of it. Don't worry if you haven't. In time, you'll become familiar with it. But basically, it's, as the name suggests, trying to harmonize internationally the language we use, the names we use, the packaging we use when we're handling chemicals, to try and reduce miscommunication. Miscommunication will often lead to accidents and incidents. So we're trying to simplify and harmonize the language we use around managing and transporting and using chemicals. Again, cradle to grave concept, which means from the point of generation, transportation, use and disposal. If we talk about transportation, there's a range of international conventions to control how chemicals are packaged, stored, transported and used. There's a list on this particular slide of those different conventions. We're not expecting you as practitioners to be able to quote chapter and verse all these different conventions, all these different pieces of legislation, but it's something we need to be mindful of. I move on now to the Material Safety Data Sheet, the acronym for which is MSDS. Every chemical used, transported and ultimately disposed of must be accompanied by the MSDS, the Material Safety Data Sheet. I would say as an environmental practitioner, this is possibly the most important tool that you have in your toolbox for managing chemicals. The MSDS is in compliance with international conventions. It's not optional, it's a must. The manufacturer must send chemicals with the MSDS. The user, in this case the oil companies, the subcontractors, must have the MSDS to hand. It must be available, it must be displayed, so that those individuals working with the chemicals are familiar with the risks they're being exposed to, are familiar with things such as the health and safety requirements, familiar with what personal protective equipment needs to be used. The MSDS will also, in detail, tell us how ultimately these chemicals need to be disposed of. So as I mentioned, key thing, material safety data sheet in the management, the regulation of chemicals broadly, but also specifically within the oil and gas sector. So that brings the first part of the presentation on chemicals to a close. As I say, just a summary slide here of some of the key learning points we need to be mindful of. The first of which is that the oil and gas sector uses a vast amount and a vast diversity of chemicals. Some of them are benign, many of them though are hazardous, dangerous to health and the environment. We have to understand the risks and we have to manage the risks. To manage the risks, we need to understand what is the composition of all of these chemicals. We can't know one component and not the other. We have to understand in entirety what the components are and what the risks are. If uncontrolled, chemicals can pose serious risk to both public health and the environment. To help you in the management of chemicals, there are multiple interlocking, interrelated national and international legislative tools, be them national laws, international treaties, international agreements. There's a host of them in place. We need to be familiar with them and how to apply them. Most importantly of which, as I've mentioned, is the MSDS, the Materials Safety Data Sheet. This will be drawn up and must be in compliance with all of these international laws and treaties. So, as a starting point, the MSDS is your best friend, it's your best tool, it's the thing that's going to help you best manage chemicals in your oil and gas sector. Thank you for that. Again, very rushed, very simplistically, but hopefully gives you an overview of some of the key points as they relate to the oil and gas sector. The second part of the presentation relates specifically to waste management within the sector, and there's a lot of overlap between use and management of chemicals and management of waste, because many of the chemicals used are ultimately going to end up as a waste product. What will we talk about in this sector? We'll talk about what is waste, why are wastes concern to us. We'll look at some of the definition of waste. So that's very important in a legal context. When is something a waste? When is it not? We'll look at some of the international frameworks, in particular the European Waste Framework Directive. In a European context, a very important piece of legislation. What are some of the specific wastes in the oil and gas sector? Waste management planning, which is a key component, and we'll just remind ourselves at the end of some of the key learning points. So, what is a waste? Waste definition. In the legal sense, a material becomes a waste when it is a subject or object which the holder discards, or intends to discard, or is required to discard legally. So it's gone beyond the point of its utility value. It's to be or has been discarded. Now, when we talk about hazardous waste, that falls under the same definition, but there's a sub-definition, which is hazardous wastes are those wastes which pose substantial or serious threat to public health or the environment, hence the name hazardous. They can be hazardous because of their characteristic, which could be ignitability, reactivity, toxicity, or corrosivity. One of these or more of these characteristics make this waste product hazardous. And again, they can be in various forms. They can be gaseous, liquid, or indeed solid.
Sorry, Mike, to cut you short. We have like 10 minutes for you to do your presentation. So.
Okay, jolly good. I've just been informed I have 10 minutes left, which is perfectly fine. I think we're on course. So again, looking at this slide, we have a fairly typical arrangement of a drilling rig. And the point to note is that at any point of the exploration production process, we are going to be producing waste of very different type, very different characteristics. At the top of the list here, we've got drilling cuttings. What are drilling cuttings? This is the rock and the sand which is going to be liberated from the well site. So the well bit is cutting through the geology, and coming to the surface are rocks and sand and soil, which are going to be covered in the drilling fluid. So drill cuttings from the well are one of the major waste management issues that we have to manage. The drilling fluids, we've talked about a little bit. It could be oil-based, chemical-based, it could be synthetic, but it's the drilling fluid which is being pumped down the well, which will be reused to the extent possible, but ultimately is going to become a major waste management problem for us. We then have produced water that we talked about previously. oil and gas being liberated, but often in association with substantial volumes of water. So produced water by volume alone is arguably our biggest problem. Can be re-injected, often isn't, leads to very significant problems. We then have secondary waste problems such as drainage water, domestic waste, sewage, cooling water, solid waste, and indeed, if we have accidental spills, all of this material is going to become a waste which needs to be managed. In terms of the treatment of hazardous waste, again, I've used the phrase before, it needs to be managed cradle to grave, that every link of its life cycle has to be managed with no inadvertent discharge to the environment. We have to recognize the fact that the oil and gas sector is a very substantial waste generator globally. Now, in a lot of countries, international oil companies are working in developing countries. The reality of that situation, if we talk about Africa, Asia, to an extent the Caribbean, a lot of these developing countries lack substantial or sufficient waste management infrastructure. So they may not have engineered landfill sites, incinerators, thermal desorption units. So if we're working in an environment where oil companies are producing waste, the host country doesn't have the waste facilities, then they have to be developed, they have to be engineered, be it long-term or imported on a mobile basis. Incinerators, thermal desorption units can be imported, or the waste itself has to be managed, packaged, and exported to a disposal facility. Now, irrespective if the oil company is American, is European, is operating, let's say, in Africa, then the oil company does not lower its standards to those that pertain in a particular African country. The important thing to remember is they should adhere to the same standards they're using in Europe and using in North America. It's my experience, very often they will try not to, but as regulators, as environmental scientists, we have to ensure the oil companies are operating to the highest standard. The physical and chemical characteristics of the hazardous waste will determine which disposal option we're going to use. In Europe, a very important piece of legislation is the European Waste Framework Directive. Now, this sets in legislation many important components, considerations, as it says there. It enshrines the polluter pays principle, which means if you generate the waste, if you are the polluter, you have to pay. Extended producer responsibility means if you're the waste generator and you give it to a third party transporter, for example, and he dumps the waste illegally, you as the generator still retain a responsibility. It's not out of sight, out of mind. And it also introduces the waste hierarchy. I think we'll all be familiar with that, which enshrines the fact that at the top of the hierarchy, the most desirable is that we prevent waste, we minimize waste, we reduce waste, we recycle waste, and only at the bottom end, only the smallest remaining fragment of waste ultimately needs to be disposed of. In terms of the management of hazardous waste, when you have hazardous waste, you have to act appropriately. The hazardous waste cannot be mixed with inert waste. It cannot be diluted. It has to be properly contained and labeled, must go to a licensed hazardous waste disposal facility, and the environmental regulator, whichever country, has to be notified of that movement of hazardous waste. So some rogue operators might want to dilute the hazardous waste, may want to mix it and get it to a chemical characteristic where it's no longer hazardous. Such approaches are prohibited in law and should be monitored and regulated by ourselves and not condoned, and corrective action needs to be taken. The picture on this slide is taken in an African country, cradle to grave. I followed the process. The hazardous waste, which was meant to be going to an engineered landfill, ended up, as shown here, dumped on some agricultural land. Very sad, very common. That's where strict regulation and enforcement is essential. We've talked about the impacts of water-based and oil-based drilling fluids. I don't need to labor that again. Produced water, if discharged inappropriately, as shown in this picture, is going to be liberating chemicals and hydrocarbons. Produced water, we have to get on top of it. I'll explain how we can do that. And that we have very many emissions to air. One of the biggest culprits of that is flaring and venting. We're saying in this day and age, flaring and venting needs to be a thing of the past. It needs not to be encouraged other than under perhaps emergency situations. How do we manage all of these different solid, liquid, and gaseous wastes? This should be encompassed in the waste management plan. When applying for a license, when the EIA is being done, the oil operator has to produce a waste management plan. With chemicals, we've got the material safety data sheet. With waste, we've got the waste management plan. It is the Bible, it is crucial. The operator must anticipate how much waste is going to produce, of what characteristic, where and when. Some of the graphs to the right would show you that I've extracted from a waste management plan. They're anticipating what they're going to generate, when they're going to generate it, and in what volumes. So the plan must identify the waste. The plan must also identify how it is going to be disposed of. If there are existing facilities to be used, all well and good. If there's not, what are they going to do? Are they going to build a landfill site, for example? Are they going to import thermal desorption? Are they going to import incineration? Are they going to stockpile, package, export overseas? When you're evaluating the waste management performance of a company, the waste management plan is your Bible. That's your go-to document. There are many options for waste management. I've mentioned some of them in passing. Ian's going to get into detail on them. We have landfilling, which is an engineered site with low permeability membranes. It's really a containment solution, relatively middle order cost, perhaps $50 per ton. Thermal technologies are more expensive, perhaps double the cost, but there is a role for thermal technology. Some waste products, some hydrocarbon products won't lend themselves to bioremediation, won't lend themselves to landfilling. They'll need to be disposed of thermally, either by incineration or thermal desorption. Ian will talk more about these in the coming presentation. There's solidification, where you try and stabilize the product, typically using cement, fly ash silicate. It does have an application, but doesn't work in all situations. If you have less than 15% solids, if you have very elevated organic levels, it's probably not going to be the technology for use. Example here of contaminants, hydrocarbons, being cemented in place to reduce their migration, to reduce their leaching. So basically, there's a range of waste products, there's a range of solutions, all of which need to be evaluated, identified, and selected in the waste management plan. Very quickly then, just to summarize with my final slide, some of the key learning points. We have to recognize the oil and gas sector is a major waste generator. Waste management is hand in glove with oil production, gas production. Much of this waste is hazardous and will need strict control, regulation, and enforcement. Some of the biggest waste products you're going to deal with will be the cuttings, the waste mud, and the produced water. Very large in volume. It needs strategic planning in advance, not at the time of when it's being produced. Oil companies must comply with best practice, best international practice. They cannot lower their standards simply because they're working in a developing country. I think my final point is just to re-stress the fact the waste management plan is the Bible, it is the key, and it will enable you to keep the oil companies on track, honest, and performing in compliance with best practice. I'll say thank you at that point. I'll pass us back over to Chi, who will do the necessary housekeeping, and I think we'll move seamlessly into Ian's production, and I look forward to your questions later in the session. Thank you.
Thank you very much, Mike, for that very brief introduction and overview of chemicals and waste management in the oil and gas sector at different stages. Now we'll be moving on to Ian to give his presentation. He's going to be focusing uh, on one of the projects he's done in Iraq.
Thank you, Chi, and welcome everybody. Yeah, I'd like to present a couple of case studies actually on remediation and waste management in the oil fields from the experience that RSK have had in Iraq over the last 7 years. We've been working in the Basra Governorate for about 6 years now in a number of the oil fields, including Rumaila, Zubair, and Majnoon, as well as West Kurna. The two case studies that I'd like to cover today relate to the work that we've done in Rumaila. You can see that on the maps on this slide, and also further east in Zubair oil field. Mike's touched upon this in his overview presentation. And what I'd like to talk about today relate to particular primary sources of contamination that we find in the oil fields, including gas vent pits, at degassing stations, leaking oil pipelines, and as Mike mentioned at several stages during his presentation, produced water pits, which come in various shapes and sizes, but very often, certainly in southern Iraq, can be very extensive indeed, covering several kilometers laterally, with a mixture of oil and water, basically just ponding in an uncontrolled fashion across the oil fields. It's very important to assess the environmental setting of a particular contaminated feature or a leak site in order to understand what the potential environmental risks might be, identifying the key receptors to the contamination in order to assess what the potential linkages might be between the sources and the receptors. In southern Iraq, in Rumaila field, we find that the groundwater, which is an important receptor, is very shallow in the north and much deeper in the south. We also find that the groundwater typically flows towards the marsh areas in the north, and that there is a significant increase in the clay and silt content in the shallow soils in the north, which is important because it significantly reduces the potential vertical migration of the oil through the sediments down to the groundwater, which is the receptor. On this slide, you can see the point that I'm trying to highlight, which is the different penetration of the oil in the north and south of Rumaila field due to the difference in the clay and silt content of the soil. So on the left, we can see a produced water lagoon, unlined, and we've excavated a trial pit into the sandy soils within a meter of the edge of the contaminated feature. And you can see quite clearly from the photograph that there is very little evidence at all of any oil impact in the excavated trial pit. And the reason for this is that the permeability of the sand, due to the high clay and silt content, is very low. And this restricts the vertical and any lateral migration of oil through the soil. In the south, however, where we have a very low clay and silt content, you can see from the pictures that the oil contamination can extend many meters vertically through the soils. And in some cases, we've found significant levels of oil contamination, even at depths below 10 meters below the base of the pit. And this can pose significant challenges when it comes to identifying the right solution for excavating of the materials. It's also very important to have an understanding of the composition of oily wastes in an oil field environment, and to recognize the difference between a fresh oil spill and the degree of weathering. From the table, you can see that in a fresh oil spill, we typically have over 60% of aliphatic and aromatic hydrocarbons in the C5 to C35 range, which is the typical TPH fractions of interest when we're looking at an environmental assessment and a remediation program, and a much smaller amount of the heavier, more complex hydrocarbons in the range C35 to C90, which are commonly known as the SARA fraction: saturates, aromatics, resins, and asphaltenes. By comparison, when we look at an oily sludge which is heavily weathered and perhaps has been weathering in the desert for a number of years, through the natural processes of degradation and volatilization in the desert environment, we see a significant reduction in the relative proportion of the C5 to C35 hydrocarbons, and a relative increase in the heavier, more complex hydrocarbons that don't typically degrade very well naturally. So you can see that the percentage now of the C5 to C35 is as low as 15% in a weathered sludge. Why is this important? Well, as the oil degrades and we get a higher proportion of the more complex hydrocarbons, this material becomes harder to remediate, certainly by biological means. However, the weathering also means that the overall hazard ranking, if you like, of the sludge compared to its fresh spill is much lower. So the sludge poses a much lower risk to the environment and human health because it contains a much lower percentage of the more toxic and mobile, lighter short chain hydrocarbons. When we're looking at the design of a remedial system and an assessment of the risk, it's very important to try and ensure that any remedial targets that we develop and negotiate with the regulators are risk-based and take into account the associated source pathway and receptor linkages that we've identified in our initial assessment. As I mentioned before, the receptors are very often in an oil field environment are groundwater and surface water receptors, but we also need to consider oil field workers and any neighbouring communities that may potentially be at risk from the contamination sources. In determining risk-based remedial targets, we also need to ideally develop individual targets for the separate TPH fractions rather than generating a total TPH remedial target. And the reason for this is that the risks associated with the different TPH fractions vary significantly. You can see on the right, for example, that we have remedial targets for some of the lighter hydrocarbons down in the range of 100, 200, 300 milligrams per kilogram. But as the carbon chain length increases, we have longer, more complex hydrocarbons. The remedial targets are much, much higher. So how do we remediate these produced water pits, these vast expanses of oil and water lagoons in the desert? It's very much an engineered approach, an engineering approach, using earthworks and heavy plant to isolate the lagoons into separate areas by creating earth bunds in order to create more manageable areas where we can then pump out any oil and water if it's possible to do so, or bail out the water into a sump or a containment pit. That's the first phase, which then allows access for us to undertake any UXO clearance that might be needed. And UXO clearance isn't necessary everywhere, but it's sadly a very real risk in Iraq, and a very important part of the project before we can actually then start excavating and dealing with the sludges and the underlying soils in a remediation setting. Once we've undertaken the UXO clearance, we then remove the sludge from these isolated phases of the lagoons, and we tend to do that by using mechanical plant, creating a levee, which we are essentially pushing the sludge to one part of one side or one corner of the lagoon. Once the sludges have been removed, they're segregated and typically stored in lined pits for future treatment. We then excavate the underlying oil contaminated soils, which ultimately are excavated and formed into windrows for ex situ excuse me, bioremediation. And I'll talk about that a little bit later in the presentation. Here you can see a couple of plans on this slide and a couple more pictures of the engineering approach to the removal of the oil and water and the sludges from these produced water pits, and the different phases of work in order to complete the overall project. We also come across occasionally much deeper features, oil pools. This particular one in Rumaila field was a very famous oil pool known as the Russian pool, essentially a former borrow pit that over the years was used as a repository for oily water and waste oil, building up to huge volumes over time. Actually potentially a bit easier to deal with than the vast expanses of produced water lagoons. The first stage in this particular example was to pump off any floating oil, and in fact the oil was recycled and recirculated directly into the export pipeline, and we managed to recover over 200,000 cubic meters of floating oil from this particular feature. We then pumped out over 600 cubic meters of water, which was put through a water treatment system and then discharged back to ground via a soakaway. The underlying sludges were then excavated and segregated for storage, and the contaminated soils were removed in layers for ex situ bioremediation. And overall, a significant quantity has been stockpiled in lined cells for future treatment phases. So how do we treat the sludges? We've actually looked at two potential options for treating the very heavily contaminated oily sludges. The sludges are quite problematic and can be quite expensive to treat via thermal and other methods. The two options that we've looked at both involve the recovery of the oil from the sludge. Given the huge quantities involved and the high levels of oil content in the sludge, recovering the oil is very important, especially if it's possible to find a reuse for the oil, because the oil essentially has a value, and this can be used to offset the price of the remediation works. So the first method I'd like to talk about is, Mike mentioned it earlier, it's thermal desorption by vapor recovery. So it's an indirect fired thermal desorption unit with a built-in vapor recovery unit, which actually distills and recovers the oil from the sludge. In this particular example, the sludge content has a solid content of between 35 and 60%. Generally, it has a very low water content, And the oil typically comprises mainly long chain hydrocarbons, 85% of which have a carbon chain length above C35. In the various pilot tests that we've done, they've concluded that generally the best recovery yield is about 20%, typically at around 400 degrees C. And we can recover about 10% hydrocarbon compared to the initial volume of sludge. So, for example, in this case, we had just over 350,000 cubic meters of sludge, and we estimate that we can remove just over 35,000 cubic meters of recoverable product with a value of about $50 per barrel. This equates to a huge amount, $11 million. When you look at the setup and operational costs on this project over a 2.5-year cycle, the overall total treatment cost is $32 million, which equates to $88 a cubic meter. However, if we can incorporate the $11 million of revenue from the recovered oil, this reduces the treatment cost down to $57 per cubic meter.
Sorry to interrupt, Ian. Just to remind you that you have 10 more minutes to round up your presentation.
No problem. The second option is enhanced separation by using a tricanter centrifuge in a heated system using steam, and the use of a diluent, which is typically a lighter hydrocarbon, for example, fresh crude oil, diesel, or even gas condensate. In this particular setup, the total cost of treatment over a similar 2.5-year cycle is $17.5 million, which gives us a lower treatment cost of about $48 per cubic meter. And if we can incorporate the value of the recovered crude, then this reduces the cost right down to $18 a cubic meter. However, these calculations assume that we're using fresh crude as a diluent, which would be provided by the oil operating company, as opposed to using diesel, for example, where there will be a cost for that. Finally, I'd like to talk about how we treat the contaminated soils. So we've removed the sludges, we're looking at options for sludge treatment, which we've just talked about. Once you get below about 10% total hydrocarbon content in the soil, there are much cheaper, more cost-effective options for dealing with the contaminated soil, and we've been doing a lot of work on ex situ bioremediation to treat soils in this category. And bioremediation applies biological processes to clean up the contaminated soil and water. It's an enzyme catalyzed transformation. It uses bacteria and fungi and algae, or a combination. And essentially the hydrocarbons are degraded aerobically and ultimately converted into carbon dioxide and water. Here we can see one of our treatment sites in southern Iraq. You can see that we've laid the contaminated soil out in long linear piles known as windrows, and we manage the windrows using a specialist piece of plant, which you can see in the photograph on the right there, which is called a windrow turner. And this essentially manages the windrows and turns the soil, homogenizes the soil, and aerates the soil, which is important in the management of the bioremediation process. Here's a picture of the typical layout of one of our sites with the windrows, which are all labeled and identified. So when we monitor them and we're monitoring the progress of the remediation, everything has its own unique identification, so that when we're reporting this, we know exactly where everything is and where the samples have come from. The most important thing to do in ex situ bioremediation, essentially what we're trying to do is nurture the microbes, create the best environment for them in the optimum conditions to encourage them to naturally degrade and metabolize the hydrocarbons. It's important that we monitor regularly on a daily basis temperature, pH, moisture content, oxygen, And also we need to add nutrients, most importantly nitrogen and phosphorus, which generally we do by adding normal agricultural fertilizer, or there are other sources of nutrients that we can use, including cattle manure. Bioremediation has been proven to be very successful in sandy soils, where we can reduce the TPH concentrations from between 70 and 100,000 milligrams per kilogram right down to 10, 15, 20,000 milligrams per kilogram, depending on what the remedial target is. It becomes more difficult in clay-rich soils, mainly because it's more difficult to homogenize the clay-rich soils, and it's more difficult to aerate them to provide the required amount of oxygen for the microbes to degrade the hydrocarbons. And actually, in some cases with clay-rich soils, we find that the TPH levels in the soil actually appear to increase at the start, and this is due to homogenization of the hydrocarbons as the soils become better mixed by the windrow turner. We can add bulking agents and organic matter into the windrows in order to provide better aeration of the soil, and to do this we often add wood chippings or straw or sawdust, which is quite effective. So the lessons learned in bioremediation, as I said before, it's a very cost-effective and can be very successful for the remediation of sandy soils that are impacted with weathered crude oil. We can even blend more heavily impacted sludges in a relatively small ratio into the sandy soil to enable the treatment of some of the sludge that would otherwise be impossible to treat via bioremediation. Urea and general agricultural fertilizer normally provides all of the required nutrients. We can use grey water to help speed up the remediation process, but this isn't essential, and more often than not, ordinary RO-treated groundwater works very well. The risk-based remediation goals for the TPH fractions within the C5 to C40 range are generally achieved within about 3 to 4 months via ex situ bioremediation in our experience. The longer chain hydrocarbons above C40, which are present, but they're generally not degraded very well. This can cause some visual impact even in the treated soils, but typically they have a low toxicity and a low solubility, so really it's more of an aesthetics issue than a risk. And planting can normally overcome any concerns over visual appearance if this is considered to be an issue. Currently, the clay-rich impacted soils in southern Iraq are being stored in lined pits. You can see in the photographs here, and this is for future treatment. The storage is defined as temporary, so long as there's a plan to treat the material in the future. So to conclude, remediation and waste management costs can often be offset by the value of the recovered oil, especially if the oils are contained quickly to reduce the volatile losses from the oil. So early intervention really captures the most value from the recovered materials. It's very important that the field program is controlled to minimize the mixing of the wastes and to preserve the quality of the oils and the sludges to maximize the oil recovery. And where possible, we should really try to use the recovery of the oil to offset the remediation costs. And this can actually make the treatment costs much more viable to the oil operating companies, even when employing thermal methods, which typically are considered to be quite expensive. We've also shown that ex situ bioremediation is an effective treatment technology for marginally contaminated soils where the oil recovery is not cost effective. And that concludes my talk. Thank you for listening, and I'll pass you back over to Chi, and I think now we'll take any questions from from the audience. Thank you.
Thank you so much, Ian, for your beautiful presentation on your case studies. We'll now be going into the question and answer session, and we've had a number of questions from our audience. So the first question we'll be taking today is what the audience wants to know: what are the main considerations for hazardous waste management for offshore upstream oil and gas? Like what are the main, what should be considered when thinking about hazardous waste management for offshore? Mike, would you like to answer?
Yeah, sure. Again, I come back to the point that there should be no surprises. There should be no unanticipated situations or waste generation. So I come back to the oil company's waste management plan, which needs to be professional and robust, needs to identify what waste they're going to generate and when and in what quantities. And they need to identify what the solution is. Is it disposal onshore? Is it within existing facilities? If the existing facilities don't exist, what are they going to do? Are they going to import portable equipment, like we were hearing from Ian, portable thermal absorption units, thermal incineration units? So bottom line is, the environmental practitioners, the regulators, shouldn't be confronted with last-minute problems of this nature. It should be identified upfront as part of the planning and permitting process, and then we monitor and regulate and evaluate their performance in compliance with their waste management plan. So it's a host of things. It's when's it going to be produced, in what quantity, what nature, what exists for treatment, is the solution to export, or is the solution to bring the treatment in a portable fashion? It's going to be a range of solutions. So as I say, it needs to be identified up front. If it isn't identified up front, then there's a problem in the planning process, in the permitting process. But it does happen, and it will continue to happen, because the processes and the licensing and the monitoring isn't as yet of a standard which can properly or regulate and manage the oil sector to the level which is desirable, particularly in developing countries.
Chi, I think you're muted.
You just pointed out that it should be the first thing that they should think about before they actually start the process of exploration or production. So we also have a question saying, like, who should be responsible for controlling chemicals and waste in the oil and gas sector? Is it the government or the producing company, or like civil society, or like, in your opinion, like?
Okay, well, my glib answer to that will be yes. In other words, all of the stakeholders you mentioned have a role to play. The generator has the responsibility of complying with best practice and complying with their waste management plan. The government sector, and it varies from country to country, whether it's the Environment Agency, whether it's the Petroleum Department, but the government sector are in the role of the monitor and the regulator. So they should be monitoring and evaluating performance against the designated standards and against the plans. And you mentioned civil society. I'm a big believer in that civil society have a fundamental role to play. Their role is as a third-party observer. I believe they should be engaged with, they should be shared. Environmental monitoring data should be shared with civil society, should be shared with communities, and they're a valuable stakeholder and they're a valuable custodian, and they have a role to play in determining that the oil companies are performing to an acceptable standard. So all of those stakeholders have a role. Their roles are separate and distinct, but complementary.
Thank you very much, Mike. And some of the audience have questions for you. So, like you mentioned, you've been working in developing countries, and there's usually an absence of waste management facilities. So we can anticipate like a growth in this particular kind of infrastructure for waste treatment purposes. So how do you ensure that these infrastructures are designed, developed, or like used in a sustainable way while providing waste treatment services? Like, is it something that should be in the regulations, or is within your company to ensure like when these facilities are built, they're like going to be designed in a sustainable way?
Well, in my experience, the development of waste management facilities in the oil fields are typically led and driven by the oil operating companies, and this is driven by their responsibility to manage the waste that they produce in a sustainable way. So they're working very often in compliance with the requirements of the regulatory authorities and the oil regulators in the country where they're operating. But ultimately, it's the oil operating companies that will develop those facilities. And it's important that those facilities have a range of technologies. It's becoming much more important. Mike mentioned, touched upon the pyramid in his presentation, and it's becoming increasingly important that we look at technologies that recover oil and other chemicals for reuse and recycling, as opposed to disposal and or incineration, which perhaps was more common historically.
And Chi, if I could maybe add and supplement what Ian said, if I use an example, when I was working in Brunei in Southeast Asia, as the environmental regulator, a very large international oil company was operating. This is back in the 80s and the 90s. Their planning horizons are 20, 30, 40 years. It's not short term. They knew approximately the volumes of cuttings, drilling fluids, produced water they were going to produce. So the oil company took responsibility to build a hazardous waste landfill in compliance with international best practice. They also built, by putting it out to third-party private sector, they built an oil recycling center and a chemicals recycling center. Now, the oil company didn't do that out of the goodness of their heart. It's business. They have to plan to manage their waste, and it's their responsibility. I've dealt with other oil companies who are less responsible, and they would look to use excuses like, well, these facilities don't exist in the country, so we will use whatever is there, even if it's substandard. But with proper regulation, proper enforcement, holding the international oil companies to bear and to be responsible, invariably, as Ian said, the capacity isn't with the government sector in developing countries, the capacity is with the international oil companies. They should identify, budget, and build whatever waste facilities are required. The spin-off, as was the case in Brunei, is the oil company in partnership with the government then opened up the landfill sites and the treatment center for public use. So for the first time in Brunei, you had an engineered landfill site that then could take all domestic, commercial waste, and it's part of their cost recovery as well, because on a fee base per ton, then that's part of their revenue generation as well. So invariably, it's going to have to be led by the international oil companies where they are responsible and where they're held accountable.
Thank you very much, Ian and Mike. So this question will also lead me to another question. You're talking about like governments are supposed to be responsible, they have to have regulations. So the UN does the UN, like, what is the role of the UN in waste migration across shores? Like, what does the UN, do they have regulations or guidelines regarding like waste migration from one country to the other?
Well, yeah, the UN's role, I would say, or specifically UNEP's role, is pretty much the global environmental watchdog. So what UNEP does is, with these environmental issues, whether it's chemicals or whether it's waste, they very often will develop international standards, norms, and conventions. We can think about, for example, the Rotterdam Convention, the Basel Convention, Minamata, etc., etc. So the UN will set international standards that countries will sign up to, and in signing up to, then it's down to the individual countries to put in place enabling environment locally. So the UN's role is at the global level, and then the country role is for endorsement and implementation within their boundaries. So it's a complementary approach at the international global level, and then filtering down to the national level.
Thank you very much, Mike, for that.
Another I just would add again,
yeah.
If a developing country hasn't ratified Basel Convention, Rotterdam, Stockholm, etc., then that is not an excuse for the international oil company to lower its standards. Irrespective, they should comply with the international criteria, international best practice, even if it doesn't pertain within the country where they're working. The international companies are very well aware of their responsibilities, and sometimes they need to be encouraged to honor those responsibilities.
Very, very important for the audience to actually know that regardless of your country ratifying any of these conventions, the companies actually working in these countries also have like a responsibility to actually adhere to like the good practices and guidelines, because they are aware of this. So someone also asked, like you mentioned the MSDS. So the person wants to know what kind of roles do like IT, information and communications, and internet, including emerging technologies like big data, Internet of Things, e-platforms, play in the industry, like for waste management, the waste management plan, and disseminating the MSDS. Do you, any of you, have an idea what the roles of IT or communications or the e-platform would have?
Yeah, I'll jump in, and Ian might want to supplement. Yeah, we have to embrace modern technology, IT, computers, everything else, and there is a role. And in the role of, if we're talking about the material safety data sheet, in the very modern world, all of this information can be put online. It can be made accessible at the click of a button to staff globally across the workforce, whether it's on a rig or a platform, sitting in The Hague, sitting in Africa. So technology plays a role. It's another way of communicating and disseminating information. But the cautionary tale for me is, in many countries in which I work, IT isn't particularly good, internet isn't particularly good, so we can't rely solely on modern technology and IT. Belt and braces is that if you're on a rig, on a platform where the chemicals are stockpiled, the chemicals are used, the MSDS must physically be there, must be pasted on the wall, must be accessible, can be accessed, can be read. So it's complementary. Absolutely, IT plays a role, plays an increasing role, but we have to recognize in many developing countries, it's still in its infancy, so we need to rely on the belt and braces approach of a physical MSDS being there in the workplace, being accessible, and staff being trained in health and safety, personal protective equipment, and what to do in the case of an emergency.
Yeah,
Ian, would you like to add something?
Yeah, I would just like to say that I think, you know, I would reiterate what Mike has said, and I think in practice, typically what you find is a combination of, you know, online web-based systems and access to information, but also, you know, the old style hard copy format is also very important, because, you know, if you have an emergency on a site and you want to, you know, you're in that situation where you need to access information quickly, you've got a safety file, you know where everything is, and you can access it immediately. You don't have to go online, worry about whether the Wi-Fi is working to access your files and folders. So I think the two go hand in hand, really.
Okay, thank you so much. So the last question, because we're like trying to be on time. Ian, regarding the bioremediation, like that you discussed, someone would like to know if bioremediation reduces oil in marine ecosystem 100%. Does bioremediation have the capability of reducing the oil spillage or oil
Yeah,
content?
absolutely. I mean, bioremediation works in both the marine environment, near shore and offshore, as well as on land. Bacteria are everywhere. Bacteria, algae, fungi, that they're prevalent in all environments, onshore, offshore, hot springs, the Arctic environments, ranges of temperatures, so that they're very, microbes are extremely resilient organisms. They adapt to all conditions, and will degrade oil in all environments. The trick with bioremediation, particularly onshore, is to control and manage the environment that the microbes are living in within the soil. So they have enough oxygen, so they have enough other nutrients and the right levels of moisture to actually do what they do best, which is degrade the oil as a food source.
G, if I could add to that, just to reinforce Ian's point, bioremediation, I think, has a major role to play. It's broad-based, it's pragmatic, it works. But just to address, I think one of the points in the question is where we have an oil spill, whether it's terrestrial or offshore, bioremediation has a role to play. What we're finding in the Niger Delta, in Ogoniland, where we're dealing with some of the biggest oil spills in the world, is bioremediation can be used as one of the tools. We're looking at thermal treatment, biotreatment, cementation, all sorts of treatments. But where we're using bioremediation, we can knock down the level of contamination well below the legislative target values. But what has to be understood is we're never going to get it to zero. That is a reality. I don't know if Ian's experience is different, but we're never going to get it to zero. What we are going to be able to do is we're going to be able to get it to a level whereby the ecosystem can recover and thrive and get back to its productive use. So there's always, sadly, going to be some residual hydrocarbons.
Yeah, no,
Great.
I would reiterate that as well. It's all about reducing the level of risk to an acceptable level. Thereafter, nature will take its course, but you'll never get rid of it all.
Yeah. Sadly, thank you so much to both of you. Your presentations have been awesome, and unfortunately, we're out of time, and we're not able to like go through all the questions, although they're like really good questions here for you to answer. But anyways, we want to thank everyone who has stayed on till the end of this webinar. Like 252 people have actually stayed till the end of the webinar, and we would like to thank them for staying. And we hope that you took away like good things from the webinar. As soon as the webinar ends, is just to inform you that you have a survey for you to fill out, and immediately after you fill out the survey, you would get soon your certificate of participation. And we'd also like to remind you again that the webinar was recorded. In case you stepped out in one of the presentations, you'll be able to watch the replay of the webinar whenever you have the time. So the link will be available shortly to your email, the email that you registered with. And we'll also like to remind you again that you be subscribed to our mailing list, so you would also get updates on our upcoming webinars, news like guidelines, job opportunities, and you would also like to encourage you to join our LinkedIn group. It's called Global Network on Environment and Oil and Gas. There you can raise the questions that which we were unable to answer, because we have some of the experts signed up there as well, so they'll be able to give you answers to the questions. So I would like to say thank you once again to Mike and to Ian. Thank you for your time. Thank you for the presentation, and thank you to everyone who has also stayed. to the end of the webinar. And our next webinar, the dates will be broadcast shortly on our LinkedIn groups and on our newsletter. So I would like to say that you should stay tuned to know when next and what topic we'll be discussing next on oil and gas environmental management. So thank you again, and I wish you a good day or good night or a good afternoon from wherever in the world you're calling in from. Thank you, and hope to see you soon. Goodbye.
Thank you very much, Chi. Thank you, Ian.
Thanks,
Cheers.
Mike.
Bye.
Bye for now.
Bye-bye.